Thank you for coming, all of you. I know about two of you. So, I'm Louis Fremkes, and Avi Loeb is a theoretical physicist who works on astrophysics and cosmology. He asks the big questions, such as, why are we here? Where did we come from? Is there intelligent life beyond Earth? And if there is, why haven't I had them speak at the Hunter Writing Center before? He has written fascinating books such as Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. At present, he is the Frank Baird Professor of Science at Harvard University, where since 2007 he has been director of the Institute for Theory and Computation at the Center for Astrophysics. You get the idea. He's smart, he's interesting, and I am delighted to present him here as your speaker tonight for the Hunter Writing Center. After his brief talk, he's going to talk for maybe 30 minutes. We'll open up to Q&A, and I hope you will develop questions, and then there are books if you'd like him to inscribe them for you, he will do so. Avi?
Thank you so much. Thank you, Louis, and it's a great pleasure to join you here. In fact, 35 years ago, I entered the US through New York City, and I have a special place for it in my heart. So what I discuss today is not only things that are beyond Earth, but also beyond the solar system. So that's an exciting frontier, and we call that interstellar because these objects came from the space between stars. And my book that I will be happy to discuss in the Q&A just came out a couple of months ago, and it's talking about the implications of finding a package that originated from a neighbor. Just like a tennis ball that was thrown by a neighbor and you find it in your backyard among the rocks. And that would have great implications for the way we perceive ourselves in the universe and the way we see our future. It will be a wake-up call to stop fighting with each other on this tiny rock that was left over from the formation process of the sun, and perhaps think about the bigger picture, that there is much more real estate out there beyond the solar system. This is a new frontier that just started over the past decade. Only over the past 10 years we found objects that came from outside the solar system, as I will describe. And for me, of course, the interest is whether any one of them is of technological origin. Just think about Voyager that we sent out of the solar system. It will exit in 10,000 years, the outskirts of the solar system, and then someone may find it and know about us. It's a completely different method than used in the past to search for extraterrestrial intelligence. Previously, people tried to detect radio signals, but that's just like waiting for a phone call at home. Nobody may call you when you're waiting. However, it may make sense to check if there's any package in your mailbox. That's a completely different method, because those packages accumulate over time, just like plastics in the ocean. They keep adding up, and they are bound by gravity to the Milky Way galaxy. So the question is there any space trash from other technological civilizations around us? And the first 3 interstellar objects were discovered, as I mentioned, just over the past 10 years. In January 8, 2014, a meteor, that's an object that was roughly the size of a watermelon, half a meter in size, collided with Earth, and the US government satellites recorded its speed, and it was moving too fast to be bound by gravity to the sun. And so that was the very first interstellar object that we know about. It was moving faster than 95% of all the stars near the sun, and also was made of materials that were unusual, material strength tougher than all the space rocks that NASA cataloged over the past decade, 272 of them. And then the second object was found on October 19th, 2017 by a telescope in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. And it was roughly the size of a football field and anomalous, unlike the familiar rocks that we are used to in the solar system, because its shape was most likely flat, pancake-like. We couldn't resolve it in an image, but it was tumbling every 8 hours, and the amount of sunlight reflected from it changed by a factor of 10. And that meant that it has a very extreme shape, most likely flat. And it was also pushed away from the sun by some mysterious force. And I say mysterious because there wasn't any evaporation, no cometary tail behind this object. So it was not a comet, yet something was pushing it. For a comet, it's the rocket effect, the same effect that pushes also jet planes. But there was nothing around this object. The question was, what is pushing it? So it was anomalous. It also originated from a very special frame of reference, which is called the local standard of rest. It's the frame of the Milky Way galaxy nearby that you get to when you average over the random motions of all the stars near the sun. And only 1 in 500 stars is so much at rest as this object was, Oumuamua. And then, in August 29th, 2019, a comet appeared from interstellar space. It was just like the comets that we are used to, so nothing special about that one. It was discovered by an amateur astronomer, Gennady Borisov. It was given the name the Borisov comet. And altogether, out of 3 objects that we discovered, the first 2 are unlike the familiar rocks that we are used to. So it raises the question, have we encountered a technological object, an object that was manufactured by another civilization? We don't know for sure, but it's worth exploring that possibility. And that's what I'm doing as a scientist. So let me first define what I mean by an interstellar object. So just imagine the sun here in the middle in red. If an object is at some distance from the sun, like the Earth is, then there is a speed above which the object will be considered as unbound to the sun. Gravity is not strong enough to keep the object bound to the sun. So the Earth moves around the sun at 30 kilometers per second. Turns out that the escape speed from the sun at the distance of the Earth is 42 kilometers per second. It's about 1,000 times faster than the speed limit in a highway on a car. So we saw these objects moving faster than the escape speed. That's how we know that they came from outside the solar system. And as I mentioned, Oumuamua was quite unusual in its flat shape. And I suggested that it was pushed away from the sun simply by reflecting sunlight. So we know that it reflected sunlight, that's how we saw it, but for the sunlight to be effective at pushing it, the object needed to be very thin, like a surface layer of a technological object, or you can think of a sail that is being pushed by wind. If you put a sail in front of the sun, it will be pushed by reflecting sunlight, and that's called the light sail. So I suggested, well, nature doesn't make such objects, maybe it is artificial in origin. But we don't know because we didn't have a chance to collect enough data on it, and by now it's too faint for us to see anymore. About a month ago, there was a play presented about my work on this object, Oumuamua, by a playwright from Los Angeles. The play is called A Piece of Sky. He wants to bring it to off-Broadway here in New York City, so hopefully within a year it will get here. And let me just mention a couple of quotes from that play. One has to do with the fact that a lot of my colleagues had pushed back against the possibility that one of these interstellar objects is artificial. They said, we don't want to discuss it. It's most likely natural, even though anything that they could think of was a rock of a type that we've never seen before. And just think about a cave dweller finding a cell phone. The cave dweller would say, it's a rock of a type that I've never seen before, and throw it away. But if the cave dweller has a kid, the kid might be curious and check it out and see that by pressing buttons, it's doing things that the rock does not do. So I'm playing the role of this kid, and everyone else plays the adult in the room. And so I say, why is childlike bullying more prevalent than childlike curiosity? You know, that's a very good question for social media forums like X, Twitter. You find bullying far more frequently than you find curiosity out there. And my advice to young scientists is never pretend to be the adult in the room. Maintain your childhood curiosity. And that's what I'm trying to do. I haven't changed much since I was a kid, if you ask people. So actually, if you wanted a shorter version of introducing me, you could say that I'm a curious farm boy. That's sufficient. I was born on a farm and remain curious. Because one of the things that bothered me as a kid was at the dinner table asking a difficult question, and the adults in the room would dismiss the question because they didn't know the answer to it. And they didn't want to show any weakness. And so I decided to become a scientist so I can answer the question myself. That's basically the reason I'm a scientist. So 2.5 years ago, I established the Galileo project at Harvard University. And the goal is to study objects near Earth and check whether any of them is of technological origin from another civilization. And so we have actually an observatory that we built at Harvard University, and it's now operating. Actually, as of the last month, we are collecting data 24/7. And we are starting to get our hands dirty in the sense of looking for things that are anomalous, not birds, balloons, airplanes, familiar objects. But maybe there is something different out there because the US government says that there are some unidentified anomalous phenomena that they don't understand what their origin is. And that includes the Director of National Intelligence. I met her, Avril Haines, I met her at the Washington National Cathedral a few years ago, and I said, Avril, you are saying you don't identify these objects, but what's your gut feeling? Because she got a bachelor's degree in physics from Chicago. And she said, I don't know. So I believe them. They simply don't know, but they are not scientists. I mean, the government is mostly concerned about national security. So I'm here to help them figure out if there is anything. They don't care about interstellar affairs. That's not their day job. But I'm trying to figure out what is in our sky using the scientific method. The government is not a scientific organization. So let me show you a brief video of the system that we have so you can be familiar with the components of it.
Welcome to an overview of the Galileo Project's development site, codenamed Pigeon Run. Our instrumentation suite consists of both wide field and narrow field sensors. Wide field sensors are used for target selection and tracking, while narrow field sensors gather higher resolution data on potentially anomalous objects. Our main instrument is DALEC, a hemispherical array of 8 infrared cameras. Next to it is the ALCOR, a secondary high-resolution optical all-sky camera. Together, these instruments continuously monitor and track objects in the sky, analyzing them in real time for potential anomalous activity. This is AMOS, our acoustic monitoring omnidirectional system designed to detect and record acoustic signatures across the infrasonic, audible, and ultrasonic bands. AMOS also houses an ADS-B antenna for logging aircraft transponder data, allowing us to quickly separate known from unknown objects. Here we have Skywatch, a multi-static passive radar system designed to detect and track multiple objects simultaneously, measuring object positions and kinematics. And Pac-Man is an environmental monitoring system for measuring local weather conditions. Sensors include an anemometer, temperature and pressure sensors, a particle counter, and a flux gate magnetometer. Next up is Spectre, a radio spectrum analyzer with a wide band antenna for measuring radio and microwave emissions. Beacon is currently our only narrow field instrument. Beacon is a high-resolution pan-tilt zoom camera capable of 40 times optical zoom. Our instruments collect a wide range of data, all of which is fed to our computing enclosure housed beneath the DALEC and Alcor instruments. Here, data is processed and analyzed in real time. Objects detected and tracked by the wide field instruments are localized in 3D space and analyzed for unusual characteristics. Selected targets are then sent to the Beacon PTZ for follow-up observation. Finally, data is recorded to disk and uploaded to the cloud via Starlink. These combined systems comprise the current version of the Observatory class system, with many refinements, additions, and upgrades scheduled for near-term implementation at Pigeon Run.
So this is the system that works right now, and we're planning to make more copies of it. Let me just move forward.
Welcome to an overview.
Okay, and then there is already one copy that we are planning to assemble in Colorado in the coming weeks, and we will make more copies as we get more funding. Each observatory of this type is $500,000 roughly in cost, and obviously it can be called after the donor that would like to support it. We want to have hundreds of them throughout the US eventually, and just figure out the nature of objects that the government cannot figure out. We also use satellite data, looking at objects from above, not just from below. And that's based on data provided by Planet Labs to us. And so we have a plan for the coming years, and the number of observatories will simply reflect how much funding we get. And we published 8 papers so far. But what I'd like to discuss most of the time today is the expedition that I led to look at the materials from the first interstellar meteor that I mentioned at the beginning from 2014. We rented a ship and went to the Pacific Ocean on June 14th to 28th this year. And I wrote 43 diary reports from that expedition, posted on medium.com. So if you just look for my name, medium.com, you will find them. They were read in real time by millions of people, translated to Spanish. There was a huge amount of interest in this expedition, which cost about $1.5 million. So this meteor was in a catalog that NASA compiled. It was detected by US government satellites. So we discovered that it is interstellar in 2019 with my student. I just asked my student to look for objects in that catalog that move faster than the escape speed from the sun. And here was this object. But our paper was not accepted for publication because the reviewers argued that they don't believe the US government data. So it took 3 years for the US Space Command. I managed to get their attention through the White House. And they issued a letter to NASA stating that at the 99.999%, this object indeed came from interstellar space. You can see the letter on the left. And then our paper was accepted, and I started planning the expedition to the Pacific Ocean to collect materials from this meteor, figure out whether it was artificial or natural, whether it was a rock or a spacecraft. And the bottom of the Pacific Ocean there at that location is 2 kilometers deep. And we were aiming to find molten droplets from the surface of this object when it was exposed to the immense heat from the fireball that was created as a result of its friction through air. And the light curve of this fireball was released by the US government. It had 3 flares separated by 1/10 of a second, and all of them occurred in the lower atmosphere. So we calculated that in fact this object was able to sustain stress that is far greater than any other space rock cataloged by NASA over the past decade. So 272 of them, and that includes iron meteorites, meteorites made of iron. This one was tougher than iron, this object. So that raised the possibility, maybe it's a Voyager-like meteor. Imagine Voyager colliding with another planet like Earth in the distant future and showing up as a meteor of unusual material strength in the atmosphere of this planet. The other thing that was unusual is that this object was moving faster than 95% of all the stars near the sun. And so that meant that it is unusual on 2 counts: materials and speed. And we wanted to localize the position of the meteor site better than the US Department of Defense provided us. They gave us this box of roughly 7 miles in size. But we were able to use a seismometer on Manus Island in Papua New Guinea that recorded the sound from the explosion. And just like in the case of thunder, you hear the thunder after you see the light from the lightning, because the speed of sound is 1,000,000 times slower than the speed of light. And so from the time delay, knowing the speed of sound, you can tell how far away the thunder was, and in this case, the explosion was. So we were able to narrow down the path of the meteor based on the distance from this seismometer to the red strip that you see on the right-hand side. So let me show you some pictures from that expedition that was just a few months ago.
Drifting myself, thinking I am where you are. Drifting myself, thinking I am where you are. Drifting myself, thinking I am where you are. Drifting myself, thinking I am.
So
Drifting myself.
So this is the team of 28 people that I assembled for the expedition. They include the best engineers and navigators for such an expedition in the world. And gladly, after announcing the intent to go on this expedition, a funder contacted me. We had a Zoom call, and he said, you have the $1.5 million. So we went there, and you see here the deck of the ship. Behind the team, you see what is called an A-frame that was directing a cable from the ship to a sled that had magnets on both sides that we dragged on the ocean floor so that it will collect magnetic particles, roughly millimeter in size, molten droplets from the object when it was exposed to the fireball. So just think about it, finding millimeter-sized particles the size of a grain of sand at a depth of 2 kilometers across a region that is 7 miles or 11 kilometers. That sounds like an impossible mission. And here in the top middle and the right-hand side, you see the sled being picked up from the ocean with the magnets. And we would bring it on the deck and then scrape the magnets for the magnetic particles that we collected. And what you see on the bottom left and middle panels is the filming crew that was with us. There were about 50 filmmakers and producers who wanted to be on this ship, and I selected one. And every morning at sunrise, I would jog just like I do on land. And then one morning they showed up and said, "Can we film you jogging at sunrise?" I said, "Sure." And they asked me to jog 3 times longer than usual. It was roughly 9 miles that I jogged that morning. And at the end, the director asked me, he said, "Avi, it looks like you are running. Are you running away from something or towards something?" And I said, "Well, I'm running, I'm doing both. I'm running away from some of my colleagues who have very strong opinions without seeking evidence. And I'm running towards a higher intelligence in interstellar space." So here you see the sled, and we would collect the particles from it using also a vacuum cleaner so that we don't miss anything. And then we would dry up those particles, as you see on the left, top left, looking at them through a microscope. And for 6 days, we didn't find any spherules, any molten droplets from a meteor. And then we used mesh to filter out the tiny volcanic ash particles that were there, the black powder. Once we did that, we found that the bigger particles are actually do contain some spherules. So that was an amazing experience. I was thrilled. I hugged the person who found the first spherule. But before I show you some images of the spherules, let me show you a video of the sled on the ocean floor, looking at it from a video camera that was connected to the cable. And you see it's just like mowing the lawn, except we're dealing with the ocean floor at a depth of roughly 1.5 miles. It's mostly mud down there, but there are some animals like shrimps that we saw. And the magnets on this sled are collecting particles that we later examined when we brought the sled up to the ship, to the deck. And sometimes we would run into an obstacle, like in this case, this rock. We don't know if it's related to the meteor or not. For that, we need a different machinery to collect bigger pieces, which is something we're planning to do in the next expedition, hopefully within the coming year. And the main challenge initially was to keep the sled on the ocean floor, because the cable would lift it up and it would kite, so it wouldn't really collect material. So we went 26 times back and forth and across this region where the meteor materials fell, and the expected meteor path is shown in orange. I knew the moment we found one spherule, I knew that we would find many more, because if you find an ant in the kitchen, you know that there are many more ants out there. That's why I get alarmed when I find an ant in the kitchen. So we found 50 on the ship, and you can tell easily how different they are from background particles of sand. They look like metallic marbles, as you can see, and we collected them with tweezers. And they're very stiff, they're very tough. And so here are some images of those spherules that through the microscope that we had on the ship. And I posted them on Medium, and my daughter saw them and said, "They look so beautiful, could you thread one of them on a necklace for me?" And I said, "That's not possible. They're smaller than 1 millimeter in size. They're tiny. You cannot thread them. They're also very tough. But they look beautiful." And so we put them in vials. These are the babies that we delivered on the ship. So it's sort of like a delivery room, except The babies here are the spherules, and they are in vials instead of in their beds. But the delivery room is this white basket that we put in a container and shipped with FedEx to my home. And I realized, I mean, the FedEx case arrived to my home. You see it on the right side. A few days after I came back, I realized that a few days of delay is not too much, because this material took billions of years to arrive to Earth. And you can see us on a rainy night on the left, scraping the magnets. That was a very common experience over there. The funder is actually the person just next to me in this photo with the black raincoat. He participated in the work. So I brought the materials back to Harvard and shared them with my colleague there, Stein Jacobson. He has a lab that is one of the best in the world to analyze the composition of materials like that. And you see him standing in this picture on the right side of me, and on the other side is my summer intern, Sophie Bergstrom, who actually I asked if she can look through the materials to see if there are spherules that we haven't found. She decided to shadow me this summer because she wants to become a science journalist, but at some point she said, "Can I help doing the science?" And I said, "Sure, why don't you check if we miss some spherules?" And she found 600 of them. So I gave her the title, The Spherule Hunter. She found 10 times more than we found on the ship. And here are some of them. And then we made a map of the yield of spherules that were found relative to the background material that we collected. And in yellow, you see the high yield regions, whereas the background is in purple. And indeed, there were 3 yellow spots that you can see that are not far from the expected meteor path. So that indicated that we were close to where the meteor exploded, because we saw an enhancement in the number of spherules. And here are some images that were taken with an electron scanning microscope. What we found is that inside the spherules there were spheres, and sort of like Russian dolls, where you have spheres inside spheres. And the idea is that the small ones solidified first, and then they were engulfed with molten iron that glued them together. And here is a spherule that looks like a soccer ball. And here is another one that is the merger of 3 that didn't become round, didn't have enough time to become round. So and this was one of the biggest spherules we had, 1.3 millimeters in size. And it was found in one of the yellow regions, so we thought we should examine its composition. So when we did that, we found that the iron isotopes have a very different ratio than you find in rocks on Earth, the Moon, or Mars. But most amazingly, we looked at the distribution of elements. And here you see them from the left to the right, from lithium to uranium on the horizontal axis. And the unit 1 represents the standard solar composition. So what we found is that some elements are far more abundant than you find in the solar system, in the standard solar composition. Elements like beryllium, lanthanum, or uranium were hundreds of times more abundant than standard solar system composition. And so clearly this indicated that there were some spherules that came from outside the solar system, because you don't find this abundance on Earth, the Moon, Mars, or asteroids. And we call it the Belau composition because it represents enhancements of beryllium, lanthanum, uranium, Belau. And here we plotted this composition as a function of the volatility of elements. Volatility represents the ability of an element to be lost in an explosion, in an airburst. And indeed, we found that elements that are high in volatility were lost from these spherules, indicating that they came from an airburst. So the question is, where did they come from? And one possible way to explain them is from a magma ocean. That's a planet where the rock was molten on its surface, and so some elements sank to the core where there is iron. Those are elements that have affinity to iron, and they left behind other elements that we see pronounced in this meteor. And so if it came from the crust of a molten magma, molten lava planet, that would explain the unusual composition. But we don't know if it was artificial or natural at this time. And actually I wrote a paper explaining how you get a planet like the Earth to eject rocks into interstellar space. You get it by making it close to the most common type of star, which is a dwarf star. The most common stars are 1/10 of the mass of the sun. And they are also 1/10 of the size of the sun. So they are much denser than the sun because the volume is going like the size to the 3rd power. So it turns out that 1/10 of the mass of the sun amounts to 100 times the density of the sun for a dwarf star. And it's higher than the density of rock. The sun cannot destroy the Earth by gravity alone. We know the moon, for example, raises tides. The oceans are moving back and forth depending on where the moon is situated. So just imagine replacing the moon by the sun. It would raise stronger tides, but it will not destroy the Earth. However, a star like Proxima Centauri, which is the nearest star to the sun, is a dwarf star, 12% of the mass of the sun. And if you brought the Earth close to it, it will basically spaghettify the Earth. It will make the Earth a stream of rocks, half of which get ejected to interstellar space. And so we just wrote a paper calculating the speed by which you get ejection of rocks in this mechanism, and it turns out to be very close to the speed of this meteor, 60 kilometers per second, amazingly. So that's an interesting coincidence, and it's possible that indeed this was a natural object that came from a planet like the Earth that was ripped apart by the most common type of star, a dwarf star. And if each dwarf star ejects about 10 times the mass of the Earth, you get enough of those rocks to explain the fact that one of them collides with Earth every decade. So altogether, this expedition was risky because there were many potential failure points. For example, I might have not secured the funding at $1.5 million for this. I might have not been successful at recruiting the best engineers and navigators. We might have not built the proper machinery. I mean, the sled would not have worked. Perhaps we wouldn't be able to keep it on the ocean floor, which was a challenge. And then it's possible that the meteor itself would not produce enough spherules for us to pick them up, going back and forth 26 times. And then finally, my colleague at Harvard could have said that he's busy with other projects, that he cannot allow his mass spectrometer to figure out the composition that we found. So I'm very grateful that we managed to get all of these lined up, and the mission was successful. And the one conclusion from that is that sometimes in life it's good to be an optimist, because life is sometimes a self-fulfilling prophecy. If I would have listened to people telling me that we would not find anything, I wouldn't search, and then we wouldn't find anything. So the next expedition potentially would be to look for large pieces of the object in order to figure out whether it was a rock or maybe a technological gadget, because a gadget may have buttons on it. So I asked students in my class at Harvard, if I find a gadget and it has buttons, should I press a button? That's a very simple question that even a kid would connect to. And so half of the class said, no way, don't do it, because it will risk all of us. Another half said, sure, why don't you do that? Because we would like to know what would happen. And then one of the students said, given the split vote, what would you actually do, Professor Loeb? And I said, well, I'll bring it to a laboratory and examine it before I engage with it, so don't worry. So let me just conclude with a slide that mentions what I've learned, the wisdom that I've learned from the many decades that I practiced science. So that's for the young people in the audience, because the old people may already have decided what their principles are. So first of all, when you are a scientist, most importantly, you follow the evidence. And, you know, the evidence doesn't fall in your lap. You have to work hard to collect it. So it's much easier to have an opinion. That's what many of my colleagues do. They have an opinion. They don't do anything. They say it's an extraordinary claim. We don't believe it. Well, you can say that without doing anything. But the hard work is actually to collect the evidence, to collect the materials, analyze it. It takes months and a lot of effort. And that should be respected more than having an opinion. And it should be done with instruments. You shouldn't believe what people tell you, because, you know, people have their own reasons to say one thing or another. And the instruments should be well calibrated and under control. And then it's important to follow the principles of FIFA. So as you know, there was a Women's World Cup this summer. And in fact, FIFA follows the principle. I mean, you could listen to eyewitness testimonies, but FIFA uses cameras to make up their mind. And that is the principle of science. You don't rely on what people tell you. You know, you don't go to the field and ask the players whether there was a goal. You don't ask the audience whether there was a goal. You just look at the video recording and decide whether there was a goal. Okay, so that's the way that science works. And FIFA understands it. But many people in the public do not, because they have an opinion. And many scientists have an opinion. But you should not listen to those. Now, there is another principle from sport that I wanted to emphasize, and that is what basketball coaches say. Keep your eyes on the ball, not on the audience. So I don't have any footprint on social media. I don't care how many likes I get, because I want to keep my eyes on the ball, not on the audience. And then there is this phenomenon that I was not aware of, but it's very, it's becoming very powerful now because of social media. These are people who are pro-science pretenders. And what I mean by that is people who claim that they represent science, even though if you look at their resume, they haven't written a single scientific paper over the past decade or two. So how can they represent science if they're not practicing science? It's just like these commentators telling the soccer players how to pass the ball. How dare they? They're not doing it. So there are many such people that write blogs. Some of them are extremely famous because they are science popularizers. But just check whether they're practicing science. If they don't listen to them. Because they very often ignore facts that disagree with their beliefs. They're not real scientists. And there are a lot of pretenders like that. And another thing is, if there are critics, one should avoid any mud wrestling, because it always gets you dirty if you mud wrestle. If someone calls you names and you reply to that, you know, why bother? Just ignore it. And most importantly, it's important to rise to the greatest heights of scientific practice where the oxygen level is too low for the critics. So once you follow the scientific method, you get results. The hope is that they will stop pecking at your neck, so to speak. And as I mentioned before, life is sometimes a self-fulfilling prophecy, so it's better to be an optimist. If you don't search, you will not find anything. Thank you.
Who has a question for Richard?
So the good news is you may find a planet that exploded with the technology in it, and then you find the technology that they had. The bad news is that might have happened 4 billion years ago, and what will it teach us? And they may not exist anymore, just like we may not exist anymore.
No, that's an interesting point. That I was just thinking when I wrote this paper recently, I was just thinking this may be a natural origin for rocks that were shot into interstellar space, and it has nothing to do with technology, okay? But you are bringing up an interesting point, which I didn't think at the time, that if there was some infrastructure on this planet, you might throw away also some of the gadgets that were there, and that's a very interesting point. Yes, although if you destroy a whole Earth, you know, whatever was processed by technology is just a small fraction of the mass. So, but so we don't know if this meteor is indeed technological or natural until we will find a bigger piece of it. And so we are planning to go again and look for bigger pieces.
I have a follow-up question.
Yeah, go ahead.
Did you ever know of or hear of a Harvard professor named John Mack?
I heard of, but I need to explain why what he did is completely irrelevant.
I know it's irrelevant, but I want to tell you.
Well, maybe I'll explain just.
I knew him.
Okay.
You know, a little bit, and a friend of mine who was a Harvard professor in psychiatry was testifying at his. First, let me explain to John Mack. He believed his patients who said that they had experiences, actual sexual intercourse, with aliens. Right. And he was a very respected psychiatrist up until that point. And Harvard wanted to throw him out.
Yes.
A little bit like what you're saying about the intellectual criticism that you might get for having opinions of one sort or another.
No,
He didn't have any physical evidence. But anyway, one of his colleagues who testified at a friend of mine who testified at the hearing said, can you prove that they didn't have sex with aliens? Obviously something that
I try to emphasize many times throughout my talk that you should not listen to what people tell you. They may be convinced of something, but when there is a car accident, people that are involved report very different things. And so my business as a scientist is not to listen to what people say, but use instruments to tell me, because the instruments do not have ulterior motives. They don't have hallucinations. They don't have wishful thinking. So I find his work to be relevant maybe to psychology, in the sense of people saying nonsense and they are correlated because each one of them heard the nonsense said by other people, but it says nothing about the physical reality. I mean, people say nonsense all the time. Why not go to Washington, D.C. and, just correlate what one politician, the nonsense that one politician says to the nonsense that another one. Obviously, they repeat the same nonsense. It doesn't make it real. It doesn't make it true. We know that from politics. We know it from many other arenas that involve humans. So that's why I say there is a better method, which is to use instruments. And here we are talking about physical objects. I'm not talking about creatures that we, interact with. I'm talking about, because to travel across interstellar distances, no biological creature would survive. With the current spacecraft that we launched, it would take 50,000 years to reach the nearest star. 50,000 years, that's the time that elapsed since the first humans left Africa. Just think about it. We had to send the spacecraft when the first humans left Africa in order for it to arrive today, with the current technologies of rockets. So it's such a long journey. And interstellar space is so hazardous because you have cosmic rays. I don't believe we would ever see biological creatures visiting us.
There are some evidence for amino acid traces in,
Yeah, amino acids are not
But
creatures.
amino acids are the basis.
They are the building blocks, yes,
So the
but
question
I
is,
mean,
could
this,
life have come from some other
yeah, but
planet?
life,
Or
just to give you an
just-
example, life needs water, okay? Hydrogen was produced in the Big Bang. Does that mean that there was life in the Big Bang? No, there was hydrogen. And then oxygen was produced in the centers of stars. You put the two together, you make water. The Milky Way galaxy has water everywhere. That has nothing to do with the existence of biological creatures. Water is a substance used by life. So the fact that there are amino acids is one more step saying, okay, there are some other molecules made out of elements that were created in the course of stars. Fine, they are used as building blocks of life, but they are not life. So the point is, traveling through space is very difficult for life forms because the conditions are really hazardous. I mean, humans, Elon Musk dreams of dying on Mars, and I don't wish him that. But if you spend more than a year on Mars, a substantial fraction of your brain cells will be damaged within 1 year. So thinking about being on the surface of Mars, all these science fiction stories or The Martian, the film, that is completely unrealistic. We have to go underground to caves, lava tubes, to protect our body from cosmic rays for a simple reason. And if we ever want to settle on Mars, it will be in caves, just like humans started in caves to protect themselves from the rain, from weather, and so forth. There are prehistoric caves where you find paintings. If we go to Mars, we go back into caves. But it just shows you that if you were, to travel through interstellar space for more than a year, and you definitely need, 50,000 years with existing technologies, there are huge problems to send biological life forms, and it's much better to send technological gadgets that are hardened to survive those conditions. You can supply them with artificial intelligence so that they will be autonomous. And that's what I expect to find if any of the objects might be technological. I expect it to be non-living. Yes?
Do you ever use other people's scientific studies to form your opinion?
Does Avi ever use other people's scientific opinions to form his opinion?
Well, science is not about an opinion. That's what I try to explain, that it's not about the opinions. It's about collecting evidence that will guide you to the right answer. So what I'm describing is the process by which we gain new knowledge that is shared by everyone. So in that process, there could be only a small number of people that recognize the potential of the evidence. That happened with Galileo. He was the only one claiming, by looking through his telescope, that the Earth is not at the center of the universe, because he saw moons of Jupiter moving around Jupiter, not around us. We are not the most important. That sounds familiar, right? Because people say, oh, well, maybe we are alone because we want to feel important. We always want to feel important. But the point is, Galileo was unique in recognizing that, but he was put in house arrest. And today he would have been cancelled on social media. So he said that the opinions of thousands of people are irrelevant. If a single individual is using instruments to figure out what really is the evidence telling you. So it's not a matter of me having ideas that nobody else accepts, or a million people having the same idea. It's not about the number of people that have the idea. It's about the scientific method of being modest, humble, rather than expressing an opinion, following the evidence. Now, what does the evidence show? In the case of these three interstellar objects, two of them were unlike the rocks that we had seen. And that is a notion that is shared by all astronomers about Oumuamua. There were papers trying to explain it as a rock of a type that we've never seen before. If you ask any of those, there were maybe, I would say, dozens of papers, any of those astronomers, whether this is a rock of a type that we have seen before, they would say, no, it's a rock of a type that we've never seen. So on that they agree, but they would refuse to discuss an artificial origin. That's so that is the
I
difference.
have one more question.
Yeah.
I'm very interested in your scientific method. However, I'm interested in a different topic, and it's human behavior and how you would apply a scientific method to evaluating human behavior.
No, that's an excellent
For example,
question.
how people determine who's attractive and who's not attractive.
Yeah. So when dealing with, I mean, people are just very complex, okay? And now we have artificial intelligence that gets to that level of complexity of the human brain, because the number of connections in ChatGPT 4 is not very far from the number of synapses in the human brain. So suddenly we realize that those ChatGPT systems surprise us. They behave in a way that resembles the human brain. So the way I think of that is, it's just a complex system that you cannot really figure. I mean, the people that lead OpenAI, they don't have an insight as to how ChatGPT works. They just see it behaving in ways that they cannot understand because it's very complex. And it's the same thing about the human brain. It would be the same thing, you know, if a gadget from another civilization visited us, we might not figure out what it's doing because it's very complex, okay? Just like AI or the human brain. In that case, I would prefer to have psychologists try to figure out what it means rather than physicists, because physicists are used to dealing with simple systems that they can figure out, but they will not be able to deal with intelligent systems. And by the way, intelligence is not restricted to humans. It could be manifested by AI. That's what we are seeing. So my point in answer to what you're saying is, in dealing with very complex systems, you have to develop a completely new method. I mean, psychologists work on that for a very long time. But in the case, what I see right now as the most promising approach would be to use AI to help us figure out complex systems. So AI itself could help us figure out if there is an extraterrestrial AI visiting us. Our AI will figure out their AI. And our AI could also figure out the way the human brain perhaps would. So AI would offer a laboratory for us. First, it would be an agent that helps us because it can digest a huge amount of data, you know, when the human brain cannot. But second, it would be like a playground where you can play with the AI system and, you know, see how it behaves differently if you change the rules of its engagement, like if you train it differently. While with humans, you know, it's really difficult because it takes so much
You
time.
could just take a sample of like 400 people, test them, and say, oh, okay, all these people, that's.
Well, that's psychology. That's what psychologists do. So there is a well-established field
I
called
just have, I'm
psychology.
sorry, I dominated. I have a particular interest in that.
Okay, but there are professionals called psychologists, and they try to do just that statistically.
Are there any other, the gentleman right there? We can only take 2 more questions. Go ahead.
Hi there. Could the composition of the spherules be analyzed for pattern?
Yeah. So, oh, you mean by pattern? You mean the abundance pattern, or?
The pattern of, like when you look at a bunch of data and you run it through an AI, it's like finding, cracking the code.
So you're
of the
talking
collection.
about the way they are organized within the object, within this
The way they are and the different properties of the elements that are in there.
Yeah.
Could
So-
all that data be analyzed for showing a pattern, like you'd find pattern in a bunch of gibberish letters that could be code?
Right. So so far, what we did was just ask, you know, what is the concentration of different elements within a spheroid. What you're asking is more sophisticated. We haven't done that analysis. We might do it in the future, but I think it's best if we get bigger pieces, because those are molten droplets. So even if you melt, let's say, a semiconductor, and you get droplets out of a computer, suppose you put a computer screen in a fireplace and it melts, you know, you could tell that it was a technological object because the abundance of rare elements is much higher than in natural rock. So, but figuring out that it was a computer screen that melted would require a bigger piece of it, and that's what we hope to get next So that's
If I could follow up,
something
are
for
the
the
spherules, are they compositionally alike?
future. We found a unique set of spherules that was alike, and that was different from anything found before from the solar system. That's
Who else had a question?
Yeah.
This gentleman.
we can have 2 more. And,
Okay, you
Yeah.
can have.
I just wanted to know your best ideas regarding the fact that the Earth is like basically 4 billion years and the
4.6.
universe is like 13.
It's a third of the age of the universe.
In that extra 9 billion years,
Yeah.
how soon do you think something conceivably like us could have
Oh.
evolved, and as a result, how advanced could they possibly be?
Yeah. So we know the formation history of stars in the universe. We measure it because we look at the early universe. We look back in time by looking at greater distances, because it takes time for the light to get to us, and we can map the history of star formation in the universe. And what we know is that most stars formed billions of years before the sun. The sun is a late bloomer, just formed recently. It's a late star. Most of the stars formed billions of years before. We know exactly the probability distribution of star formation in the universe. So the point is, there were many opportunities, tens of billions of stars like the sun in the Milky Way galaxy alone that formed billions of years before the sun, okay? And if they had the same technological clock, if it took 4.6 billion years for technology to emerge next to those stars that look just like the sun, then those civilizations were able to do what we are doing billions of years ago. And it takes less than 1 billion years for spacecraft that we make, for example, Voyager, to cross from one side of the Milky Way galaxy to the other. Less than 1 billion years. So they could have arrived to us by now, even though it takes time, it takes 1 billion years. But so the answer is, yeah, in fact, it's the most, the only argument against it is to say we are unique and special, and we represent a very low probability event that didn't happen anywhere, which is, as crazy as it might sound, it is the most popular view of scientists that you ask. They would tell you that it's an extraordinary claim to think that something like us existed elsewhere. And I say no, it's actually arrogant of you to say that this is unusual, because I don't think very highly of our civilization. If you read the morning news every day, it's actually not very intelligent. We have 2 wars right now, and fighting for land and resources on this tiny rock, instead of working together towards prosperity. That would be a sign of intelligence if we were to work together. But we're not doing this. And I can easily imagine a more accomplished civilization that explored space, and by now its gadgets are all around us. Why not? And I hope that I will be able to find clear evidence for that, so that it will be a wake-up call for our civilization. We will start paying attention to more important things.
Anyone
There was
else?
one more question. Yeah.
One last question, go ahead.
Actually, boy, it sparked more than one question with all of this, but first of all, thank you for your work, and I guess what I want to ask is, on that last note, actually, as you kind of try not to fall prey to the herd mentality and follow your own intuitions, maybe you could say a little more about the optimism that is driving you, and as you continue this work.
This is an excellent question. A few years ago, both my parents passed away, and I realized that we live for such a short time that we better focus on substance. And that's when I said, the hell with it. There was this object, Oumuamua, that appeared to be weird, and everyone said it's a rock of a type that we've never seen before. It must be a rock. And I said, no, it could be also artificial. And so when I wrote the paper, it was accepted for publication within 3 days, and the referee was very supportive. But as soon as the public's attention grew, and the media, which according to the New York Times magazine profile that they made about me two months ago, I'm the most well-known scientist right now. So once that happened, and a lot of my colleagues, I think, started being very negative, perhaps because of jealousy. I don't really care about it because I don't have any. I'm just following my curiosity, and at this point, I don't need any approval. I was chair of the astronomy department at Harvard for 9 years. That's 3 terms, the longest-serving chair, and I was chair of the board on physics and astronomy of the national academies, and the founding director of the Black Hole Initiative and current director of the Institute for Theory and Computation. So I was very much part of the establishment. It's just that I did it as a service to my community, but fundamentally I'm always curious about, and this is such an important question that I decided not to give up on it, because the public cares a lot about whether we are alone. I think it's an aberration of academia to ignore it, and to argue that it's an extraordinary claim, that there might be someone out there. And I say extraordinary evidence requires extraordinary funding. So all we need is more donors to provide funding for this research, and we could figure it out. And amazingly, the US government is very interested. They visited my home multiple times, there are about 2/3 of the Americans that believe in extraterrestrial intelligence, more than the fraction that believes in the biblical God. Just think about it. And the public funds science through taxes. So how can the academic community ignore this question and say that we shouldn't even bring up the possibility that one of these interstellar objects was technological, which is pretty much what they're saying. And to me it sounds like common sense, but common sense is not common.
Thank you, Avi. If any of you would like to purchase a book and have Avi inscribe it for you, he will be happy to do that. And if not, we have some refreshments, and thank you all for coming.
Thanks for